Lesson 29, systems of three equations and three variables. We're going to go through the long way to solve this so that you're, again, so that you can appreciate the simple way that I'm going to have you solve that the book doesn't go into, okay? So when we're talking about systems of three equations and three variables, they aren't limited, systems of equations aren't limited to two equations and two variables where we're trying to solve something like two linear equations, solve for the coordinates where they cross, right? We can deal with three systems with three equations where we get something like ax plus by plus cz equals d, okay? We deal largely with x, y, and z in these equations. Systems of equations in three variables require three equations to solve. And the solution to a system of three equations in three variables is what we call an ordered triple. All right, so you imagine this for a second, is that you are solving for something that no longer takes place on a coordinate plane, because a coordinate plane is two-dimensional, right? It has length and width. Now we're solving for a coordinate position that has another dimension to it, okay? So imagine if we were trying to find a specific point in this room. We're not dealing, we could find a specific point on this board, it's two-dimensional, but to find a specific location in the room, we need to not only need to know our length and our width, but our depth. So that's kind of what this is talking about, even though they're not going to get into it visually. And it's denoted as x, y, and z. Similar to two equations, systems of three equations can be solved using elimination. And they give us a process for going about this. So this is the 5-step process for solving this if we were to solve it pencil paper, and we were going to do at least one of these pencil paper, and at least one of them, probably the same one, I'll show you how to do on your graphing calculator, okay? So the first thing that we want to do is we want to use the first and second equations to eliminate one of the variables. You're going to be given three equations. We're going to reduce it down to two of them, and then do whatever we have to eliminate one of the three variables amongst those two equations. You follow me so far? Okay. Then we're going to use the second and third equation. So we're going to use one of them that we used and the one that we didn't use, and we're going to use elimination to eliminate the very same variable. Okay? All right? So we're going to use the second and third equations to eliminate the same variable as we did in step 1. From steps 1 and step 2, there's now a system of two equations in two variables. Okay? So we're going to solve the system of equations that are results from step 1 and step 2. So the equation that I got as a result from step 1 and the equation as I got as a result of step 2, right? Now we're going to solve down again for one variable. Okay, substitute the values for the two variables found in step 3 into one of the original equations to solve for that third variable. We'll check our solution by substituting the values for the three variables into each of the three original equations. That seems really complicated. It's not terrible, it just requires a lot of steps. Okay, there are three possible results when solving systems of three equations. You can either get one solution, so where all three of these things cross. There are infinite many solutions, or there's no solution. A system with one solution will result in an ordered triple of three real numbers. Could be a fraction, could be a whole number, an integer of some sort, to all three equations. If it's infinitely many solutions, obviously that it defines three equal planes, and that's really what we're talking about. Each of these equations represents its own plane. So if there's an infinite many solutions, it would be equivalent to stacking three sheets of paper on top of each other. They're in the same plane at that point, okay, at least as far as we can visually represent. Or if there's no solution, it's a system with no solution. It describes three parallel planes. There's no solution because the planes never intersect. Okay? Kind of like files in a filing cabinet. Okay, a system that has at least one solution is called consistent. A system that where they're all parallel is considered inconsistent. Those are the only two things we really have to worry about here. Okay. All right, so let's try to find, that's from the other class. I may not have pulled this one up. Give me a second here. All right. I think you guys have some of this in front of you. Okay, so here's an example of one. All right, we've got 4x minus 3y minus 5z equals 36, minus 2x plus 3y minus 5z equals 30, negative x minus 3y minus 5z equals 21. All right, you guys have this in front of you. Is this the same one that you guys have? Okay. What I'm going to do at this point is I'm going to go back here. Let's see if I can find it. Okay. Now, I want you guys to give me those three equations, okay, because I don't have this sheet of paper in front of me. Eric, will you help me out here? What's the first equation?
4x minus 3y minus 5z equals 36.
Okay, and give me the second equation.
Negative 2x plus 3y minus 5z
You said negative 2x plus 3y?
plus 3y
Plus 3y.
minus 5z equals 30.
Okay.
Negative x
And I'm going to put this off over here, okay? Negative x
minus 3y
minus 3y
minus 5y
minus 5y.
equals negative 20.
N-
20, not negative.
21. Okay, so our first step is going to be dealing with these first two equations. All right, can anybody see which variable is going to be easiest to eliminate?
Y.
Y. Okay, so I'm going to add these two equations together and the y's will cancel out. Okay, that's step one. What I get, what's 4x plus negative 2x? 2x. Right? What's negative 5z plus negative 5z? Negative 10z. And what's 36 plus 30? 66. Okay? Now, so that's the conclusion of step one. Step two, okay? Okay, we're going to pick one of those two equations to bring over here with this equation. Okay? It would probably be easiest to use equation number 2 because I want to eliminate the same variable. And if I look at this closely, you know, I'm using negative 2x, again, plus 3y, minus 5, and this should have been a z. I messed that up. Nobody called me out on it. Okay? 5z equals 30. And do we see how I can still add those together and still eliminate the y's? Okay? So what's negative x plus negative 2x? Negative 3x. Negative 1 plus negative 2 is negative 3. Okay? All right? And then we have negative 5z plus negative 5z gives me negative 10z. Okay, now I've got 21 plus 30 is 51. So that was step 2. Okay? Step 3 is we take these two equations together. We have 2x minus 10z equals 66. We have negative 3x minus 10z equals 51. Okay, now I want to eliminate another variable. Okay, what variable could I eliminate? Z. What would I have to do with these two equations to get those things to eliminate?
Multiply by negative 1.
I could multiply by negative 1, okay, but then I would have to rewrite an equation. Could I subtract these two equations?
Yeah.
Okay. What is 2 minus negative 3? What happens to those negatives? They cancel out, right? They become positive. So that becomes 2x plus 3x, which is 5x. Now my 10s cancel out because negative 10 minus negative 10 is the same as negative 10 plus 10, right? All right, so that will cancel these out. All right, and I'm getting 66 minus 51. What is that? 15? Okay, now I can solve for x. Divide by 5. What does x equal? X equals 3. Okay, now step 4 is I'm going to go back into either one of the two equations that I used in step 3 to solve for variable z. Okay, so let's just pick the first one. So we're saying 2, we're substituting in 3 for x, minus 10z equals 66. 2 times 3 is 6, minus 10z, that's ugly there, equals 66. Okay, subtract 6 from both sides. We have negative 10z equals 60. Divide by 10, z equals what? Negative 6. Okay, so we've got x equals 3, z equals negative 6. My last thing to do is to solve for the variable that I eliminated. Now that I have an x and a z, right, it doesn't matter which equation I plug it into, I should be able to solve for y. And this is about to make me sick, this screen bouncing up and down. All right, so step 5. You guys have, let's see, the first equation started with what? It was 4, right? 4x. So 4 times 3, we're going to call this step 5. Okay, what was after that? 4x minus 3y. Okay, we don't know what y is, so we're going to leave that. What was the z part of that first equation? Minus 5, so substitute in negative 6, equaled what? 36. Okay, so 4 times 3 is 12, minus 3y plus 30 equals 36. Right, combine like terms, negative 3y plus what, 42 equals 36. Negative 3y, we're going to subtract 42 from 36. Should give me what, negative 12? Negative 6. Oh, I was way off. Negative 6. All right, divide by negative 3. Y equals negative 2. Oh, so it is just 2. I'm sorry. Fix that. Y equals 2. All right, so the way that we're going to write this up, okay, is x, y, z. Okay, 3, 2, negative 6. Now, let's figure out how we can get our calculators to do this work for us so that we can check our work. So do we have our graphing calculators? Okay. Okay, so I'm going to pull our paper back up. Okay. I got my graphing calculators. Everybody have one? Huh? Come grab one. Do you own one? You need to get one. Okay. All right, so we are going to set this up as a matrix. Okay. Again, like I said, this is something that the book isn't going into. All right, so notice if I look at this as a matrix, how many rows does it have? 3, right? 1, 2, 3. And look at the columns. 1, 2, 3, 4. Okay, so I want to set up, I'm going to go second matrix, I'm going to edit, I'm going to hit a 3 by 4 matrix. Now I'm going to plug in my numbers. So I got 4, negative 3. This is the big mistake people make, is they lose those negatives, right? Those negatives are important. Those subtraction symbols are negative numbers for those coefficients. Okay, so we got 4, negative 3, negative 5, and 36. Don't get nervous about the equal sign splitting those things up. We'll show you that it will turn out okay. Negative 2, 3, negative 5, 30. Okay. Negative 1, negative 3, negative 5, 21. Okay. Do we have all of that input? Okay, I'll wait on you. You let me know when you're ready. And then your calculator might be a little different this next part that we're going to do.
On the negative x, that's negative 1, right?
Yep. Yep, negative x is negative 1. Okay, let me know. We're good? All right. So now we're going to hit second quit. We're going to go back into second matrix. We're going to go over to math inside of that. Are we good there? Yes. Okay. We're going to go down to something called RREF. Should be on B. We find it? Okay. Hit enter. And now we want to select that matrix that we just made. So matrix A, I'm going to close that up. And what it will give me, it'll give me an identity matrix, a 3x3 identity matrix, okay, representing the left-hand side. But on the right-hand side, it's going to say 3, 2, negative 6, representing in order from top to bottom X, Y, and Z. Did those match our numbers? So we did it right. We did our 5 steps right. All right, and the reason I show you this is because could we get a question like this on the ACT someday? Yeah. And if you do it right, if you do those 5 steps right, you'll get the right answer. And if you plug it in your calculator, you'll get the right answer. Which one is going to take more time? The 5 steps. Where are you more likely to make a mistake? The 5 steps is where you're more likely to make the mistake. Does the ACT care if you show your work? No. Okay, I want you guys to be successful, as I talk about the ACT a lot, because for $45 and 4 hours of your day on a Saturday, that could be worth tens of thousands of dollars to you. Okay, is it worth knowing how to use your calculator? Yes. Okay, so now what I want you, I don't know if it shows up, the rest of these are all fairly similar. Yep. I'm going to hit stop on this, and then, I'll jump back there, and I'll help you with your calculator. Okay, that's about, the rest of these are fairly similar. So if you have questions, let me know. But I'm going to stop this right here because I know we chewed up.